Hello everybody, I am Omar and this is Abdurrahman. We are students of Introduction to Decision Analysis and this is our presentation for the project report. Decision analysis is obviously a very important part of our lives and we take decisions in everyday life. It's part of our life. Subconsciously, we know that there are four universal elements of making decisions. It's basically the objective of making this decision and what are the alternatives that we have, what are the options that we have that we can take, the consequences and the states of nature, which is the uncertainty. To actually be efficient in life in decision making and to obtain this skill, it is necessary to practice decision making and decision analysis. We need to apply these elements into logical frameworks. So we will present our project on solar farm site selection using decision analysis methods that we've learned throughout the semester. We'll define the problem, show our analysis using expected monetary value, utility, sensitivity tests, and finally share our conclusions and recommendations. Renewable energy is now a global priority. But one of the hardest steps in solar projects is choosing the right site. That decision involves uncertainty in prices, irradiance, and policies. Our goal is to use decision analysis to determine the best site choice. Okay. The problem definition. So basically, we are comparing three different sites: Site A, Site B, and Site C. The differences are the land lease cost, irradiance, grid connection, and grid connection costs and environments. And the objective, obviously, since this is a business, is to maximize project value while managing risks. We have been we had the freedom to choose the data that we will collect, if it's going to be assumptions or real data. We actually did we took both. We used hypothetical data but realistic estimates with multiple sources that we found on the internet that are cited in the report. Site A has a $2 million valuation if it is favorable and 1.2 if it is unfavorable. Site B 1.8 and 1.3 if unfavorable, and as Site C is 1.6 million for favorable and 1.1 million valuation for unfavorable, and these are the probabilities that we've used in the data. This is a payoff matrix. We will actually be showing it to you in the report. So as you can see, this is a payoff matrix. And these probabilities are derived from average solar irradiance data, market volatility in electricity prices, and maintenance cost variability. They represent realistic uncertainty levels while keeping the analysis tractable. So the decision problem is represented with a single decision node. This is the decision tree construction that we have made for this specific project with the EMV calculations, as you can see here. This is the decision diagram. We're not very good at drawing on, that's why. So the following figure represents the decision tree for the solar farm site selection problem, and this is the influence diagram, which models the relationship between decision variables and uncertainties and the overall project value. Yes. So from here on out, I will pass these slides to my friend, starting with the utility and risk profile.
Yeah, so now utility will be we will have three risks. Risk number one, natural, and risk seeking, and risk averse. So we will start with the risk natural, that site A, highest EMV. Uh, then risk seeking, site A will be higher upside, and then the last risk averse will be site B, safer and lower downside. So, and sensitivity analysis. The key test, it's the price drop minus 15%, and the site A is still the best. O minus O and M cost rise. Site A is still the best, and the last is minus site B surplus AFP over than 76%. This results in sensitive to probability assumptions. And did you move it? Yeah. And the value of information, additional Erdian's studies cost 50K, and potential benefits, avoid poor sites choices, save more than 100K. And in the conclusion, positive VOI. The conclusion. Yeah, in conclusion, to conclude, site A is the best under current assumptions. Site B can be better under some conditions or for risk average investors. And the last, site C is the least favorable. Recommendations. Our recommendations, we will have 5 recommendations. For recommendation number one, proceed with the site A. Two will be negate land negation. Sorry,
Negotiate
land less cost. Three, conduct audience studies to improve certainty. Four will be monitor policies and prices. And then the last, risk. Okay, risk average investors may consider site B.
And these are the references that we used. Going back to our report, just to recap on the conclusion that we just did. So basically, the presentation really presents our report, and this report has analyzed the decision problem of selecting the optimal site for solar energy with the uncertainties. And apologies for the video, it shut down on its own. Three alternatives are there: site A, site B, site C, as you have seen, where we evaluated using decision analysis tools. In the base case, site A had the highest EMV, making it the best choice as risk neutral decision makers would choose. Sensitivity analysis really brought light to site A generally remained the preferred opinion. Shifts in certain parameters, such as increase in land lease costs or higher probabilities of favorable conditions for site B, could change the ranking. Basically, it really comes down to three biases: risk neutral, risk seeking, or risk averse. Both risk neutral and risk seeking investors would prefer site A. However, risk averse decision makers may lean towards site B due to its slightly more stable returns, which is very understandable. Overall, site A is the most co-effective site under baseline assumptions. Our recommendations, being both of us being risk seeking students in this university, we would definitely recommend us going to site A. And thank you. And for risk averse investors, we would also consider site B as a safer alternative for them, but it wouldn't be for us. Thank you for listening. That is it. Here are the references that we used.